in this second tutorials. So today we discuss, and first that's mean you show your answer first. That's mean how the solution of that questions. Okay. So for the first question, first chapter. Okay, for the first chapter, you have learned about the communication system, the principle. That's the first basic that you need to know is from the informations. That's mean the original signals, and then when we want to transmit to another place or in the distance. For example, you want to send image from your current place to your friend that is far away from your place. So that means that image need to transform first, and after that, at the device of your friends need to change to the original signal. So that is the basic of the communication principle. So we have the analog signals. Okay, we have the analogs. That's the analog is the signal that's usually continuous, and it is not that means the image is, for example, the sound, image and video. That is the analogs. And for digital is okay, for analogs is continuous like this. And for digital, it have that means only at certain time it have amplitude. So that is the digitals. And for example, we have the analog clock and digital clock. So for analog, it continuous, and for digital, it's only, for example, only at the seconds. For we have hour, minutes, and seconds, and we don't know the value between the seconds. So there is the digital. So you need to know the what is the benefit of analogs and digital signals, and analog and digital modulations. And for the from the signal, okay, for the signal, and then we have the transmission channel before the receiver get it. So this is transmitter, and then here we have the receiver. And this transmission channel, we have the wired and wireless. So both wired and wireless have the advantage and disadvantage. So you need to know the advantage and disadvantage of wired and wireless transmission channel. And for the power, it's measured in decibel, and decibel is 10 for dB. Then log P1 over P2. Where's the P1 is the input and is the output. And for the dBm, the M is the milliwatt. And for the dBV, V is the voltage. And mu microwatt. So you need to understand this. It's dB is divided by reference power. So at the bottom is the reference. The P1 over P2, P1 is the reference. And then we have the SNR. Okay, before that, we have the noise. That is the formula of noise. What is the formula of noise? You cannot hear me. Can you hear my voice?
Yes.
Okay. So, what is the formula for noise?
Noise power ke tak?
Yes. The noise power. That is, we have the from the Johnson formula. What is that?
KTB tu ke tak?
Yes, KTB, the thermal noise that, but usually it's said as noise. So that KTB, what is the value of K?
1.38 times 10 to the power.
Yes, 1.38 power of negative 23. And T, what is the value for T?
Value of
Kelvin. Yes, for the Kelvin, if given the Celsius, how to change from Celsius to Kelvin?
is 200.
Plus 273.
Yes, plus 273. So this is the way the formula for the noise. Day we have the internal and external noise. For that means some of the questions we have the internals and external noise. So we use the T internal and T external. So bandwidth usually same and K is constant. Bandwidth if the B is the bandwidth. Bandwidth in hertz. So usually it's given megahertz or kilohertz. So you need to consider that this mean parameter. This mean we have K times by 10 power of 3 with mega times 10 power of 6. So that is the noise. And then for chapter 1, we also have the SNR. SNR is SNR is SI. That means signal output over signal over NI over SO over NO. So there is the formula of SNR. SNR is signal noise ratio. Okay, there is signal noise. So signal noise ratio. And for this one is the basic formula for the SNR. But if we have the cascade amplifier, so we can use the Friis formula. The Friis formula where the it means F equal F1 plus plus so for the freeze formula, we have the F equal to F1 plus the F2 minus 1 over G1 plus F3 minus 1 over G1, G2. So this one, F is the, what is the value, this means F is formula for what? Noise figure or noise factor?
Nice figure.
No, noise factor. This is for noise factor. Okay. From if it's given the noise figure, how to change from noise figure to noise factor? The relationship of noise figure and noise factor. What is the formula?
10 log
10 log
F.
F equal to
The 10 log
10 log F equal to NF. Okay, so this is noise figure. NF is noise figure. So noise figure in the dB. Okay, in the dB. And then for the this formula, this freeze formula, you need to use the linear form. Linear form. That means if given dB in the questions, you need to change shift log. So this means from dB to linear. So you need to change from dB 10 log F, and then you need to get the F here by changing from dB to linear form. So when the linear form, you can use this formula. So also for the gain, if the given is dB, you need to change to the linear form. Okay. Any questions for the first chapter before we proceed for the first example? Okay, you need to understand. This means if the okay, for example here, for example, is given the dB only. Okay, this is dB only. But if the noise figure given in dBm, you need to change. This means 10 log P over 1 megawatt. So you need to know how to change from value this. This means the milli, micro, V to the linear form. So you need to consider this one. This only dB or it is dBm or either one. So you need to change based on the parameter given. Okay, if no questions, so we proceed with the first. Okay, for the first example, okay, we have the done in microwave laboratory with following specification. We have the 1 gigahertz. 1 gigahertz is the frequency, and then 200 megahertz is the bandwidth, and temperature to 290 Kelvin. So, and then the received signal amplified by 3 different amplifiers with connected cascadely. The first amplifier A with noise figure. Okay, so the given is F equal to 1 gigahertz, and then bandwidth equal to 200 megahertz, and then temperature equal to 290 Kelvin. And then the received signal is amplified by 3 different amplifiers with connected cascadely. So we have the A with noise figure is 5 dB, and then the gain is 10 dB, and is set as first amplifier of the sequence. The choice of remaining 2 amplifier can be chosen from below. This means we have amplifier B, C, and D. Okay, this is that's mean for B, C, D, we can choose either 2, but we can just write here first. For the B, S and R I equal 20 dB, S and R O equal 10, gain equal 5. Okay, and then it's given the C. C given the gain equal to 30 dB. Noise figure is 10 dB. And we have D. D is gain equal to 100. And then F equal 2.51. Okay. So we have this is the questions. So, so this one is G equal to 5. Okay, for the first questions, the A, show that noise factor is directly proportional to the output noise power and inversely proportional to the gain. Okay, how you do this for the first questions? Any one of you?
Using noise factor formula.
Using noise factor formula. So, what is the formula for noise factor?
F equal to SNR I over SNR naught.
Again?
F equal to SNR I over SNR naught.
SNR. Oh, and then?
Then SI over NI. Then the overall over to S naught over N naught.
Okay. And then from here you can get SINI dot NO SO. and then
I assume SI equal to S naught.
SI over S naught. Okay, you cannot assume SI over S naught because S naught actually is GSI. We have gain here. So okay, for the question, this means the questions want you to show that the noise factor. Okay, this is the noise factor F is proportional to the output noise. Okay, so for the these questions wants you to derive the F proportional to the NO and inversely proportional to the gain. So 1 over G. Yes. Okay, for the okay, until here, when you assume SI over S naught, and then how you prove it?
Oh, I missed it. So the last one is S naught over G and I.
S naught over G
And not over G and I.
and not over
Over G and I and I.
and then this means how you get this?
Because G equal to SI over S naught, but this but this one is SI over S naught, so like so it became 1 over G. So N over G and I.
Alright, okay, I understand. So that's mean you get that G equal SI over S naught, and then from here we have okay, actually G is S naught over SI. Okay, from here and not G and I. Okay, okay, this is the this mean from here you already get this mean until here you also can prove that the F is proportional to NO because from this mean we assume here is constant, but for this one okay, S naught is GSI. The output of this the output signal is the amplification of input signal. So SO equals GSI. So put this in the formula. So F equal SI over NI times NO G GSO. Sorry, GSI. Okay. And then from here, you can see here. So from here, we have okay NI. NI is KTB. This T is based on the I, but we can use KTB, and then because the KTB is constant because this question have this means the same KTB, so we can assume that F equal to N naught over Ni over KTB G. Okay, from here F is proportional to NO, and then inversely proportional to the G. This means you need to use G to that means G is from the signal output. SO equal NO, so you will get G. Until here, okay. For these questions, you also can prove until here, but it's better if you you put the noise equal to KTB and KTB is constant, so you can prove that the F is proportional to NO and inversely proportional to gain. Any questions for this first question? So, do you solve like this or you have another answer? You can share with all of us. If you have your answer, we can discuss. It can be accepted or not. Okay, Angelique, you want to say something? No. Okay, for the second, okay, for the B is determines the output. Okay, sorry, this is mu actually. The second one is mu. This the dBm and dB mu. Okay, so the second questions wants you to get the Ni in dBm and dB mu. Okay, what is the formula for Ni? What's the formula for Ni? KTIB. Okay, what is the K?
1.38 times 10 negative 23.
What is TI here in this questions?
290.
And what B?
200 megahertz.
Okay, 200 mega need to write it 200 times 10 power 6. Mega is 10 power 6. Okay, when you calculate it, you should get 8 times 10 power of negative 13 watt. Do you get this answer?
Yes.
Okay. This is the in watt, and then in dBm you need to use this. This is the Ni, and then dBm 10 log 8 power of 10 negative 13 over M here is 1 milliwatt. This is what. So when you calculate it, what is the answer here?
Negative 90.
Yes, negative because it is 90.86. 90.969, so you should use 91 dBm. Okay, so this is the first answer. And the second one is dB mu. Q is the formula for dB mu. Over
1.
1 microwatt. So when you calculate it, what is the answer that you got?
Negative
Negative
60967.
609. Yes, 609. But you can use 61. B mu. So this is the answer for B. Okay. Okay, and then see what will be the total noise factor for the sequence A, B, C. Okay, for this one, this means use the amplifier A, B, and C. So, use A, B, and C. So for A, we have the NF equal to 5 dB, G equal 10 dB, and B is SNRI 20 dB, SNRO 10, and G is 5. For C, G is 30 dB, and F is 6 dB. Okay, for the total noise factor, what is the formula for total noise factor?
F1 plus F2 minus 1.
Okay, F1 plus F2 minus 1 over
G1.
G,
One.
G1 plus F
3 minus 1.
over
G1, G2.
okay, G1, G2. And this one, use dB or not use dB?
Yeah, not dB.
Not.
Not use. Okay, so this one need to use linear form. So okay, so you need to the dB formula you need to change it. So here for the F1 you need to get from the first. So NF1 equal to 5 dB, and then F1 equal to shift log 5 over 10. And then G1 equal to 10 dB. So in linear form, G1 is 10 power of 10 over 10. And then for the F2, okay, F2 is because noise factor is SNR input over SNR output. Okay, so you can get from here the SNR input is Okay. For the this one SNRI given in dB, but SNRO linear. So you need to formula for F is SNRI over SNRO. And then SNRI given is 20 and 10. 20 dB and SNRO is 10. And then here 20 dB need to change it. It is become 20 over 10. Okay. So you it is hundreds and then so the F2 is hundreds over 10. So it's become 10. And then the G2 is the given is 5. Okay, 5 is already in the linear. So you no need to change from dB to linear. And for the because formula also only us until F3. So need to get the F3. So the F3 is from the noise figure is 6 dB. So you need to change 6 over 10. Okay. So the F total equal to F1. F1 is 10 power of 5. This one is 10. And then plus F2. F2 is okay, 10. 10 minus 1 over G1. G1, okay, 10 power 10. So this is 10 plus F3. F3 is 10, 6 over 9 minus 1 over G1, G2. What is the 10 and G2 5. So you should get the answer is 2. Okay, what is your answer?
4.12.
Should be 4.1 something. 4 point. Yeah, should be 4.15 lah. So this means the answer for 4.1 somethings, you get the right answer. So any questions for this?
Yang for F3 minus 1 over G1, G2. Is it
Which one?
last one. Is it supposed to 10 times with 3.2
Again?
for G2?
Hmm?
I think I'm
Yeah, because this question also confusing. This means because some of the value given in DB and some are not, but you need to aware of that. So you need to aware of the this mean the value given in DB or not. So if not in DB, so you it is in linear form. So you can use that value, no need to change. But if in DB, you need to change to linear form before use the freeze formula. Okay?
Doctor,
Yes?
for the final answer, we have to change it back to the B or not?
No, because it's asked for noise factor, not noise figure. So the answer is 4.15. So any this means 4.1 somethings is correct. Okay, any other questions for the first example? So yes, in the test there will be noise questions, but I'm not really sure what type of noise. But you need to familiar with this formula. That means the formula for the freeze formula, and then the DB. That means how to change from DB to linear forms. And then if DB in DBM, we need to change to linear also, how to change it. And what is the other? Usually it's all about that lah. Okay. Any other questions for this? If not, we proceed with the second chapter. That is, the second chapter is amplitude modulations. Okay, for the amplitude modulations, for the amplitude modulations, you have learned about the formula for the amplitude modulations. That means the VAM. Okay, the basic formula is EC EC plus VMT cos omega CT. Okay, this is the for VM, that is for the full AM. Basic is EC plus VMT cos omega CT. And then this VMT is the modulating signal. And okay, before this in the lecture, I just give example on the VMT have only single frequency. So that's the single frequency is the singleton. So another name for that single frequency modulating signal is singleton. So if the message signal contain more than contain multi-frequency, that is more than one, so it's multi-tone. So for example, if the VMT, okay, this is VMT, is we have the sorry, this is EM1, FM1. So that means we have one first frequency, and then we have second frequency here. Okay, so this means it have many frequency. So you need to put all, because this is VMT. So you need to put all this into these equations, because this is the basic formula, and from this you get the M. For the amplitude modulations, the modulation index is M. So this means the multi-tone or double tone is referred to the number of frequency. Okay, and then you have learned about the generations. So we have the balance modulator, and we have the the direct and indirect for the generations of the for the AM modulations. So for and you need also know about the frequency spectrum. So the amplitude is C over the EM over 2. So this is FC, and this FC plus FM, FC minus FM. Okay, another one is this is generations, direct and indirect. And then you have list also about the demodulations. So you have the envelope, and also use the balance modulator. For balance modulator and local oscillator is same. Okay, so proceed with the first questions. Okay, for the second example, is related to chapter 2. So we have an amplitude modulations. AM transmitter is modulated with VMT signal. Okay, this is the example for the multitone, because we have this F1, F2, and F3. And for for the first questions, ask for for the first questions, ask for formulate the overall DSBFC. So DSBFC is the full AM. And how you solve these first questions, the A questions?
Good.
Katira,
Use previous formula VAM
VAM
T
equal
EC
EC
plus
plus
VMT
VMT
bracket
omega
omega
CT. Okay, so what is the EC here?
doktor.
Yes,
Kita tak perlu masukkan cos ke kat WCT tu.
perlu.
Cos
Because
omega CT ya.
sorry. Yes. Sorry. This one is cos omega CT. Okay, so this one is cos omega CT. Okay, so what is the EC here?
40.
Okay, 40. So 40 plus, okay, what is the VMT? Okay, VMT is the full this. All of this is VMT. Okay, so for the first is 10 cos 2 pi 1000 t plus 15 cos 2 pi 4000 t plus 5 cos 2 pi 6000 t. Okay, this one is times by cos. Okay, omega is because given is frequency, so 2 pi 100 k t. Okay, from here you need to expand it. So you will get 40 cos 2 pi 100 kt plus 10 cos 2 pi 1000 t multiply. Okay, this one is multiplied by this. So it is multiplied by cos 2 pi 100 kt plus 15 cos 2 pi 4000 t and multiply by cos 2 pi 100 kt. Okay, this is the second, and for the third we have the 5 plus 5 cos 2 pi 6000 t times cos 2 pi 100 kt. Okay, this is the full, and then we need to use the trigonometry identity, that is cos A cos B equal to cos A cos B equal to 1 over cos A plus B plus cos A minus B. Okay, after you, this means from previous, you use this trigonometry identity, you should get the answer is the first is 40 cos 200. That means 2 pi 2 pi multiplied by 100 is 200k 2 pi 100 plus 5 cos 2 pi 101 101 kt plus 5 cos 2 pi 99 999 kt plus 7.5 cos 2 pi 104 kt plus 7.5 cos 2 pi 69 kt plus 2.5 cos 2 pi 106 kt plus 2.5 cos 2 pi 94 kt. So here is the answer from the expansions. Because okay, you should get this answer for the A because this is related to the B. For B, the yes.
If the question asks for VAM, we have to expand, or it's okay if we just leave without expand the equation.
For if the question only asks the VAM, it's okay. If not expand, but for this one because the second is one the spectrum, so you need to expand it. So because the first is okay, this is the EC, and then FC, and okay, this is EC, and this is FC, and this is all the detail for the sidebands. So for here, we have 40 here, and then second is 5 and 7.5 and 2.5. So also here 5, 7.5, 2.5, and you put this value at the frequency here. Okay, any questions for this?
Doctor, for
Yes.
this question,
Hmm.
I didn't expand the equation for A, but then for B, I calculate separately. That means for the sidebands, I did omega C plus omega M, and then omega C minus omega M. So is it okay?
Oh, okay. It's also can do like that. This means for the V, this means full DSBFC, you just not expand, and then this one you use the equations formula to get the frequency spectrum. Okay, it's
Yes,
also
okay.
can do like that.
Okay, thank you, doctor.
Okay, and then for the okay, for this one, the this mean the third questions is as the power. So the total power is P total equal to PC plus P sideband, because we have all this one, and then so for the equation for the sideband, another equations we okay, for the PC is equal to EC squared over 2R. And then for sideband, you also can calculate one by one, but you also can use the formula of MEFF square root over 2. Okay, so for the MEFF square over 2, you should get the answer is 0.21875, and this is C for T squared over 2R. R is 1, so you should get the 800 watt. So the P total at these two, so you should get the okay, what is your answer? Yes.
I got 887.61.
How you solve it?
I use PT equal to PC bracket 1 plus M squared over 2.
Bracket 1 plus
M squared over 2.
square over. This means this M for each sideband.
Yes. For the M, we find for all VM, AFM, and then M equal to M1 square, M2 square, M2 square root.
Okay. Yes, this means P, so your equations you use like this, right?
Yes, doctor.
Okay, so you can use this one, and then for this M1 squared over 2 plus M2 squared over 2 plus M3 squared over 2. So your answer should, the total P total is 887.5. This is the answer. Okay, any questions? Okay, this is the power of amplitude modulations. Okay, this is the power for amplitude modulations. Okay, and the second example for amplitude modulation is balance modulator. Okay, for the third example, is balance modulator is a circuit that can generate or detect a DSBFC, double sideband suppressed carrier, or single sideband signal. The output of a balance modulator can be further processed by filtering. Using the concept of balance modulator, filter, local oscillator and amplifier, draw the suitable block diagram for generating the DSBFC, DSBSC and SSBSC. Show the output based on mathematical concept. Okay, this is questions related to generations of amplitude modulations. So balance modulator is the functions of balance modulator is like mixer. That means it mix the message signal with the carrier signal. Okay, so first one is draw suitable block diagram for generating the DSBFC. So how you draw this? Any of you can share your answer? Yes, Aisha or Shakira?
The empty as the input and then the empty the balance modulator.
Hmm?
The input also the VCT.
The input also?
There's two input, the empty and VCT.
Okay. And then
The output is the empty, so it's C plus the empty cos omega CT.
and because this question, that's mean using the concept of balance modulator, filter, local oscillator, and amplifier. So where you use the filter and amplifier?
Amplifier for the EC.
Yes, for the EC. And then filter
For the cos omega CT.
Okay, filter for the from the answer. That means because from DSBFC we also can get the DSBSC and SSB by filter at the certain region. Okay, for these questions, has to use the balance modulator. Balance modulator. And then can generate DSBFC, DSBSC, and SSB. Okay, for first you need to know the relationship of these three. Okay, for the SBFC, we have frequency spectrum like this. So we have the FC plus FM, and FC minus FM. Okay. And then for the DSBFC only have the, because it not have the carrier. So we have the FC minus FM, FC plus FM. And then the third one is only one. So we have the FC minus FM, or this means either one, either upper sideband or lower sideband. Okay, so this is the first, second, and third. Okay, how to use this balance modulator? Okay, for the full AM, the direct method use the balance modulator. So we have the balance modulator here. This one you can get from the how we generate the direct balance modulator, direct generation of the DSB. So we have EMP here, and here only cos omega CT. And this cos omega CT actually come from the local oscillator. Because from the question, it said that use balance modulator, filter, local oscillator, and amplifier. So from here, we have the cos omega CT from the local oscillator, and then use the amplifier. This is the amplifier with the amplify is. This means amplified by EC. And output from this balance modulator. This means balance modulator is same concept as this. So it's multiplying both this. So this is the input, both two. So we have VMT cos omega CT. And then from here, we have the, we add both this. So the output here is EC plus VMT cos omega CT. So this is the formula of DSBFC. Okay. From here, okay, this is the basic one that you need to understand. And then from here, okay, the DSBFC, you will get here the frequency spectrum like this. And then how to get the DSBSC, we need to remove the carrier. Okay, remove the carrier. Here from the same okay, because we don't want the we don't want the EC because for the DSBSC we don't want the EC, so we not have the EC here. So the filter is take out from here. From here and use filter to FM. The size of the filter is 2 FM because this is the bandwidth is 2 FM. So this is band pass filter with 2 FM. The bandwidth is 2 FM. So you will get the DSBSC. Okay. And from here also, because here we don't have the EC, so use the filter this one it just set the filter of USB or LSB. Filter USB or LSB. So we get the SSB signal. Yeah. Yes, it is a bit tricky questions that you need to understand the concept. This means this also not include. This means the lecture only state the general is use the balance modulator and then it's not detailed, but for the test you need to understand the whole theory and apply how to generate this signal. Okay, can you understand the block diagram?
Doctor, so that means we cannot just direct take the block diagram from the lecture notes too.
Yes, cannot because for the it's based on the questions because for these questions it's as the only the which mean the balance modulator, filter, local oscillator. So for the in the lecture note, it's somehow is same because from the lecture note it said that after the SBFC use the BPF. You also can use that kind of block diagram because it's also have the same answer, but that's mean for these questions the answer like this because the theory of the SBFC, and SSB can be generated like this. That means from the basic DSBFC and then can generate by filter it. Because for in the lecture note is you can also can use that, but to be creative you need to understand the whole theory and apply answer like this.
Doctor,
Yes.
soalan tu dia minta show the output based on mathematical concept. So yang untuk DSBSC dengan SSB tu kalau tak tulis equation for output tu tak apa ke?
Because the question asks you to show the output based on mathematical concept, you need to show it's this means you also need to show the mathematical concept for this one. This means you need to show a bit the mathematical concept, how to get the SBFC based on, okay, for example here we have the VMT equal to EM cos omega MT, VCT equal to EC cos omega CT, and then after go through the balance modulator, after balance modulator is become V. So for the this one, sorry. So from the LO, this is from the local oscillator. Local oscillator only have the cos. This is from the local oscillator. So VMT times cos omega CT. And then after that, it's go through the adder. And after go through the adder, it will become EC plus VMT cos omega CT. Okay, so this is the formula for the DSBFC. And then to get the DSBFC, the SBFC, it go through the filter with 2 FM, and then okay, so for the DSBFC, because it's not go through the EC, it will become only VMT cos omega CT without the EC. And then just okay, for the SSB, because we don't have because the SSB is more on the frequency spectrum. For the mathematical equations, it's hard to explain. So just state that go through the filter USB or LSB. Okay, this is the first questions. That is the A questions for the block diagram of balance modulator. So you need to understand the functions of the balance modulator is mix the both. This means multiply both signal. So for the mathematical is multiplication. So for example like this. So for the mathematical equation, just show a bit how this means what is the VMT, what is the EC cos omega CT. Even you don't have the full answer like this, I still consider if you write a bit mathematical equations. Okay, for the second, if the balance modulator has been used for the circuit detection of DSBFC and SSB, implement this concept in the receiver circuit. Using mathematical equation concept, show how the modulating signal can be obtained. Okay, for this one, for show how the modulating signal. Okay, this one is the demodulation. It's been from modulated signal, and then get back the original signal or the message signal. In this one, before in the lecture notes, we have the for the full AM, use the envelope detector, and then for the DSBSC and so on, use the local oscillator and then the filter. Okay, for this one, for the full AM, we also can get we also can demodulate the signal by using the balance mixer or the local. Okay, this mixer is balance modulator, the same as generations. So for we have the VDSBFC, and then it's go to this mixer. This mixer actually the balance modulator, same. For mixer and balance modulator is multiplier. So it's mix and multiply both this. So VCT, and then this is the go to the local. Okay, use the concept of DSBSC. So this is so based on the mathematical analysis in the DSBFC. So here this is this one is for the after the mixer, it is multiplication of both these. So we have the This is easy. Easy plus VNT multiplied by cos omega C. This is cos omega C. Okay. And then sorry. Okay, this one is this is the VDSBFC, and here multiply by cos omega C ct, and you should use the trigo identity. Cos A cos B equal to 1 over 2 cos A plus B plus cos A minus B. Okay, this is the concept. So after you expand it and then go through the low pass filter, it will it only pass the low frequency. So for the frequency of omega C, it's removed. So only get the omega M. Omega M. Okay, so this is the how to show how the modulating signal, and then based on the this one, this means the difference is this input for the full carrier the have EC, but for the DSBSC no EC, and for SSBSC only have either one. So the concept is same for the background. This means at the back block diagram is same, only change the input because input is based on the modulated signals. Okay, this is the second. Okay, for the third, you need to third chapter. You need to know the formula for the phase modulations, the ESP. And then for FM, the difference is KF and here, differentiation. Okay, and then the relationship of PM and FM is integration and differentiations, and angle modulation formula is angle modulation formula, and also the angle modulation. Okay, index for the beta equal to KF EM over omega M, or KF EM also same as frequency different deviations. Okay, this is the concept. Okay, for this for the first example, for this one we have the frequency modulated signal is this is the VFMT. So from here you need to use this one, VFMT equal to EC plus EC omega EC cos omega CT plus representation of VMT dt. Okay, from here you change back into to get the VMT. For example, here it is the okay. This omega 0.005 sine 2 pi. Okay, this is sorry power of 5, power of 4. Okay, this is KF VMT. Okay, so you write like this: KF integration of VMT equals 0.005 sine 2 pi 10 power 4 t. And then from here, you, you will get that KKF is 10 pi. 10 pi times VMT dt equals 0.005 sine 2 pi 10 power of 40. And then differentiation of VMT dt equals 0.05 sine 10 power of 40 over 10 pi. And then for the this one, to get VMT, we need to differentiation both. So VMT dt equal to dt all of this. So the this is sine, and differentiation of sine x equal to cos x. We need this one is given in the this means we will have 2 page of formula. So you need to apply that formula. So sine x equal to cos x. So this one it will this is because this is a, this means sine ax, and this one need to put at the both at the bottom. So the answer given here, the last answer is here is 10 cos 2 pi times 10 power of 4. Any of you get this answer? For the VMT. Any questions for these questions? This means you need to understand that to get the VMT, this is the integrations of VMT. And to get the VMT, you need to differentiate it. Do you understand for this? Yes.
I got the same answer, but then my method is different.
How's your method? This means how you solve it?
I compare the beta is 0.005 with the equation of Kf Em over Fm. Then I find the Em from the equation.
Mhm.
And then after I got the Em, and then I found the equation BMP.
Oh, okay. Yes, you can also use that concept. That's mean because this VFM is 0.05. How you get the beta?
The beta from the equation, because the equation said that it is the frequency modulated signal. So the beta, I took the 0.005 because I compare with the equation EC cos omega CT plus beta sin omega MT.
Oh, okay. So yes. You also can use that method to solve it. So the first is because this equation is EC cos omega CT plus beta sines omega M. So you get the omega M, and you also can get EM from the beta equations. Yes, you can also use that kind of steps to get the answer for the VMT. Okay. What is this? Okay, for the calculate the maximum frequency deviations and maximum minimum instantaneous frequency. Okay, the solution. What is your answer for maximum duration and minimum?
For maximum,
Yes,
for the maximum, I got 100.31 k hertz. Is that correct?
100. 100 what? I cannot hear you.
100.31 kilohertz. Oh,
Okay, this is the solution. So it's mean for uh, the B is one the maximum frequency deviations, maximum and minimum instantaneous frequency. Okay, for the deviations, from this is from the equations of omega I. If you see, yeah. Okay, for this one is based on omega I t equal d dt theta I t. Okay, and then from okay, this one is omega, and if you want to get the f I t, it is 1 over 2 pi. It is 1 over 2 pi d dt theta I t. And then this is the theta I t. That's mean this full. So this is theta I t. And after you solve it, you should get this answer. And for the this is 50 here. Okay, for this one, I forgot how to solve this. Okay, this is the schema how to get the answer for this math. Okay, for this one, this is the F FC plus delta F. So the delta F max is this means if we use the t equal 1, so we get the 50, the delta F max, and then instantaneous frequency maximum plus delta F and instantaneous frequency minimum minus delta F. And for the third questions, because the beta is 0.05, so the beta is less than 1. So this is the NFF, narrow band frequency modulations. We proceed for the last question before we end. Okay, for these questions, the magnitude spectrum of cosine tone modulated FM is shown here, and the carrier frequency carrier signal is Vc equal 20 cos omega ct. Based on the information given, determines the modulations index. Okay, this one you get from the Bessel table. Okay, from the Bessel table, this means you should use the Bessel table, and the EC around like this. This means the number here. So for this Bessel table is beta equal to 2. And then for for the time domain expressions, that's mean VFMT, based on the Bessel table, and the V bandwidth is 2 nfm. So from this mean the maximum minus minimum, we get this is the bandwidth of this signal. And from this equation 2 nfm, you can get the fm. So the fm is 12 kilohertz. You put back here is VFMT is EC cos plus omega CT cos omega CT plus sines beta sines omega MT. So from that equations, you can get the formula for the VFM. And then the third is maximum frequency deviations, maximum frequency and minimum instantaneous frequency is same as previous questions. So you can get the delta F equal beta FM. Okay, this is based on the equations of beta. Beta is delta F over FM. So you arrange a bit that equations. So you can get the delta F. And the Fi max is Fc plus delta F. And Fi min Fc minus delta F. Okay, that is the solution for the you have the for another two. Okay, I will edit this schema and add the not given answer here. And okay, I will share this schema in the e-learning. Okay, and after this also, I will share the plagiarism form. You need to fill in and send back to me via the Google form. And also for today, okay, I will upload the questions around 3 p.m. So and then I will give the password at 5:20, around like that. Okay, any questions for today's tutorials and today's tests?
Doctor,
Yeah.
can you please share the recorded lecture, today's recorded lecture?
Okay. I will share it.
Thank you, Doctor.
Okay.
Saya nak tanya,
Yes.
kan yang modulating index untuk FM kan, yang beta, beta tu.
Yes.
Beta sama dengan delta omega over omega m, sama dengan delta F over FM kan. So delta F tu sebenarnya apa doktor?
Delta F tu sebenarnya deviation frequency yang formula dia sama juga dengan KF EM.
So delta F dengan delta W omega tu sama ke?
Oh, delta F dalam frekuensi dalam hertz. omega dalam radians. So daripada radians kepada hertz kena bahagi 2 pi.
Oh, tapi
pi.
okey faham.
Ha.
Okey, terima kasih doktor.
Okay, sama. Okay, any other questions? Okay, for this one, for amplitude, usually, okay, for amplitude, in voltage or in voltage, but it's if given in another symbol in another parameter, you need to change back to. That's mean if given in dB or so on, so you need to change based on the log. Okay, if no other questions, so we end this class and we will meet this exam. This exam should be asynchronous. At the evening, but anything, any update, I will inform in the group. Okay, thank you.
Thank you, Doctor.
Okay, all the best for today exam.
Thank you, Doctor.
Okay, you're welcome.
Thank you, Doctor.
Okay, you're welcome.